Once again, we have learned the idea of how to count the charge, baryon number, strangeness of the quark, and let's try to do some more practices. Here we have got a few questions, so let's try question 26, 27, 28, 29, 31, 32, and 33. Notice that some of the quark content are not provided by the question, and so feel free to go and Google it yourself. Pause the video now and I'll check the answers with you later on.
A few moments later.
Alright, because it's rather straightforward, so I've put down all the answers already and I'll go through it with you verbally. So first of all, the first question asks you to find the quark content of anti-neutron and anti-proton. Assuming you already know the quark content from the textbook, which is UUD and UDD, what you have to do is just to put a bar on top of each quark. And so this is what it is. It also asks you to verify the charge, whether it's correct. So if you try to check the anti-proton, they will find out -2/3, -4/3 plus 1/3, and that will be -1. Okay, just simply by looking at your data booklet, and you know for example, U is 2/3, and you reverse it, so become -2/3. Similar for anti-neutron, and it should be 0 for the charge for anti-neutron. Question 27, again, you just have to put a bar onto it. It asks you to find the anti-particle of it, so anti-U and regular S. Baryon number of these, I don't think you even need to check, because you know this is anti-baryon, so it's actually -1 simply. Question 29, to give better presentation, I will do it like this, so I recommend you to follow this. So question A, left hand side we have only 1 for baryon number, so because this is a proton simply. Right hand side you got electron and also a photon, and none of them are a baryon, so 0 plus 0, so that would be 0, and that is not the same to the left hand side, and that means it's violated obviously. For part B, you can have proton and antiproton, so obviously it will become 0, they will cancel out the baryon number. And for the other two, not because they cancel out, it's simply because they are both meson. Pion is a meson, and so it's 0 plus 0. This one is fine, it will be conserved. For part C, left hand side is the same, and for right hand side again, pion will be 0, and then these two, one will be positive, one will be -1. So eventually it will also be 0. So left hand side, right hand side are both 0. Lastly, for D, this one is a particle that has been given a quark content already, and so you can see it's a baryon obviously, because you don't see any anti-quark, so obviously it's going to be 1, or if you can try to calculate, that's fine as well. Right hand side, again, these are meson, so 0 for baryon number, so again it is violated. Question 31, it asks you to find the charge of this one, so just go and check out the data booklet. D is -1/3, strange is -1/3 as well, but this is NTS, so +1/3, eventually giving you 0 charge. For strangeness, once again, remember that just check this actually. S, the regular S, has a strangeness of -1, so for NTS it's actually +1. And so yeah, that's part A. Part B, it asks you about the antiparticle, so I will just find out the antiparticle that would be anti-D with the regular S, and well, if you look at the content, they are not the same obviously, so cannot. In fact, the only kind of particle that can be their own antiparticle is the one that obviously it must be meson, and also the two quark are kind of the same kind. So for example, if you have U and anti-U as a kind of meson, whatever name it is, then obviously its antiparticle is going to be the same, as you can see. So it has to be a meson and also the same kind of quark. Next one, it asks you about the meson with the quark content, whether it's charged, so just check it. I think it's very simple. Strangeness, there's no strange quark, so 0. Lastly, 33. Again, this time they have provided you some of the quark content, but then not all. So you should be able to find on Google, or earlier we have mentioned that pion positive, pion negative, and also sigma positive. Okay, and so they ask whether or not the strangeness is conserved or violated. So basically asking you to check the strangeness on each side of the reaction. So part A, left hand side, we got 0 because just simply by looking at what you have. In fact, you can just actually look at this, just see which one you have strange quark or anti-strange quark, and for the rest you can just ignore it. So well, actually if you have pion, then you can basically ignore pion, and for the rest they all have one, either strange or anti-strange. Okay, and proton, you know the content, and it doesn't contain strange quark. And for cation, it does 1 for the NTS, and then the other one would have a strange, so a -1, so eventually it will be 0, so it is conserved simply. So for sure that this is not the weak interaction, if you have to link to the idea of interaction we learned earlier. For part B, again, proton, again, this is not proton. Like when I first see this textbook, I find this typo and I didn't even know what this is. So eventually I realized this is a typo. It's actually referred as the pion neutral, which is this one, and it doesn't really matter because it doesn't contain any strange quark. Same as the neutron, so no strange at all, so that's why it's 0 here. On the right hand side, again, it is 1 and -1 because it contains a strange quark and also an anti-strange quark, so eventually 0, again conserved. Part C, you just have to refer to cation, neutral, NTS, and so NTS is +1 for strangeness. Right hand side are pion, and pion are nothing with strange quark, so 0. So you can see this one is violated. Okay, you can write down the sentence there. Lastly, for part D, again, ignore the pion here, and then proton doesn't have strange quark, ignore the pion, and then here we would have the positive, so 1 strange quark, so that would be -1. Left hand side with 0, again it would be violated. So that is to say, C and D, that two reaction, if it is possible, then it will be done by weak interaction.